Hi everyone, so welcome to the third video in this basic stable diffusion series. Today we're going to talk about text-to-image and ControlNet using the automatic A1111 interface. So we'll start with a basic sketch and produce a rendering from that. We'll then move on to maybe a little less abstract sketch and see what kind of visualizations we can produce. And then we'll start with an Arctic view from a recent project model and try to produce some visualizations using that as the input. So we'll also produce images that look like this using text-to-image with two control nets in a single generation. So we'll use both inpainting and canny edge detection to sketch over an existing piece of architecture in an image that we find and generate something different in its place. Just a couple of updates before we get going. I've added two more checkpoint models for the standard stable diffusion. They're not XL models to the enhanced based folder in that installation video, the first tutorial. So I added architecture exterior and realistic vision so that we have more options for this upcoming tutorial where you'll want to be avoiding the XL models and sticking with the standard stable diffusion control checkpoint models. I also added a standard stable diffusion in paint ControlNet model to that enhanced base folder. And again, this is not an XL model. The in-painting features with for XL, I think, are still in beta. So the standard stable diffusion models are going to be the best for this tutorial. Okay, so let's get started with text-to-image using ControlNet. So I'm going to stick with the real ArcViz checkpoint model and keep my VAE set to automatic. So what the automatic VAE selection will do is automatically assign the variational autoencoder based on the checkpoint model that I've selected. So this one here is for a Stable Diffusion XL model, and this one is for a standard like 1 or 1.5 Stable Diffusion model. So if I choose like Juggernaut XL here and then this standard non-XL VAE, they're going to be incompatible, so it's going to result in an image that either looks horrible or just nothing is produced at all. So let's get started here with the ControlNet, excuse me. Let's click in here and then we'll explain a little bit about the interface. So I'm just going to start with a really abstract sketch that I made, just super quick, Sharpie on white paper, and scanned it in. So in the interface, we've got three different ControlNet units. I haven't used all of these before, but they're just duplicates of one another, and I think it's for allowing you to chain them together so you can use multiple control nets for the generation of one image. Here we've got the single image, batch, and multi-inputs tab. I've only ever dealt with the single image, but feel free, obviously, to explore the rest of those. Down here, there's a few things that we need to check every time we use the ControlNet feature. So we need to obviously hit enable, turn on the low VRAM to kind of optimize your computing power. We'll click Pixel Perfect and allow a preview, which will bring up a preview window of the ControlNet mask here. And so the two control types that have come preloaded in that enhanced base folder are canny, and we've got two types of canny. If I hit the refresh here, I'll see I've got Control XL canny and I've got Control SD15 canny. And so just like the VAEs, this is an important note. I want to emphasize this a little bit. These control canny or depth models need to correspond to the type of checkpoint that you're using. So I'm using real ArcViz XL. It's an XL model, which means I need to be using the Control XL canny model here. I can't use the standard Stable Diffusion 1.5 model because I won't be able to generate an image, and when I try to, I'll get an error message over here. So for my preprocessor, I'm going to select Canny for this trial. Down here, I don't need to change anything. Leave that as Canny. Over here, I've got my XL model selected. And when I want to see a preview of that, see what that's going to look like, I can hit this Run Preprocessor. And here you can see that the Canny edge detection has read my sketch and produced a mask that that emphasizes those lines, those sketch lines. So we'll get into tweaking the control weight later on, but for now, let's just generate something. So let's say, what do we want to generate? Modern entertainment center. Architecture, mixed use building, city center. Let's try that. I'm going to leave the negative prompt blank. Let's also add rendering. And just keep it simple and try that out. So if at any point it seems like nothing is happening and you want to be sure that you didn't get an error or something like that, your command prompt window will be open as long as you have this interface open. And you can check here before a status is indicated on the actual web UI, you can check your command prompt and see what's happening. So I've still got 0%. I don't have any error messages, so I think it's fine. And now we see that it's going to start loading. We can see the image in this window. And it looks like this generation is going to take quite a while, so I will speed up this part of the video. Okay, great. We've got a result here. We only generated one image, and it looks pretty weird. Yeah. So let's because the image that I put in was at a 16:9 aspect ratio, I'm going to change my generation to match that. So hopefully we get a little bit more maybe context on the side of the sketch, on the side of the generation, and just a little bit more of a full picture of a building. Let's increase the batch size to 4. Let's reduce the CFG scale down to 2. And let's try to use the same trick we used yesterday to get a bit better prompt here. So I'm going to open up my GPT. I'm going to open up Diffusion, and I'm going to go to, let's see, types. Let's check out civic centers. And let's try something like this. There's a nice photo. Copy that image. Go into Claude. So I'm just saying generate a stable diffusion prompt for the materiality, setting, image style, and context shown here for a sports and entertainment center. And we'll see what we get. So it's saying it's recommending a prompt. Okay, so let's take that prompt, replace our really basic one. Our CFG scale is lower, sampling steps are at 20. I'm gonna turn it up to 30. We adjusted our aspect ratio to match that of the input sketch. And we're going to leave our control weight at 1. So the lower we go with the control weight, the less we adhere to the canny edge detection. And down here is another important control that we have. So typically, I'll adjust the control weight, and the rest of these sliders, I'll leave them at their default values. But the one thing that I will adjust down here after the control weight is my control mode. So do we want a balanced control mode where the ControlNet and the prompt are sort of equally important? Do we want a control mode where the prompt is more important? Or do we want the ControlNet to be more important? And depending on what you select here, you can get a good variety of results. For this sketch, because it is such a loose, quick sketch, I'm going to say the prompt is more important. So we will still be adhering to the ControlNet, but it won't sacrifice maybe like the architectural logic as much for how things appear to be coming together in order to achieve the control. So a lot of times when you choose like the ControlNet is more important, images can sometimes look a bit more uncanny, a bit less realistic, because they are following this sketch logic and trying to make a building out of something which isn't really sketched to be like that. This is just a super quick kind of like maybe formal study or something like that. So we're gonna say prompt is more important, and we're gonna select generate. Okay, so it looks like that finished up. It took a while. Let's check out the images. So we can see that it's conforming to the ControlNet really well, really nicely, and getting some unexpected results from such a quick sketch. You can see how basically all of the lines are accounted for in some way and producing architectural renderings in the style of our reference image. Now, is it a modern sports and entertainment center? I'm not so sure. I think those qualities are kind of been overridden by the context that we've placed it in, but nonetheless, they're great images and a great way to exploring how maybe these geometric relationships from the sketch can be translated into 3D space. So I think next let's try a bit of an elevation sketch. Let's go here. So maybe this is a little bit more straightforward, a little bit less abstract than how it could be translated into the elevation of a building. So let's say, what do we want? Let's say architectural rendering. Excuse me. White concrete. brushed aluminum. Glass. Let's say frosting glass. Exterior stair. Intersecting rectilinear and spherical volumes. Let's say we want elevation rendering orthogonal view. And let's add that we want a city context. Overcast sky. Okay. Wow. Yeah, so these are interesting translations of this image. See, we're still capturing the kind of formal qualities of the sketch in all of these. The sphere seems to be left out of most of them, but that might be improved if I turn the CFG scale up a little bit. Let's go to 5 and try to adhere that prompt a bit more. Let's try trees and flowers. And let's try to get a little bit of color. Oops. Okay, so let's get the CFG scale up a little bit higher, and let's try to let's change this here. So we can use canny, or we can use depth with what came preloaded in the enhanced base folder. So we'll see what the depth map does here. On a sketch, it's actually not that useful, but it's good to just take a look. So what this does is it reads the depth of the image and produces more of a depth map with shadows and light areas. We'll use that in upcoming tutorial section here, but for the meantime, let's just stick with the canny edge detection for this kind of image. Okay, so that just finished up. It looks like we've got more emphasis on vivid, bright, and colorful, and natural park context. Wow, these are pretty great. Okay, so we can see how the change in prompt really affected this, and the increase in the CFG scale. These are very interesting images. Okay, so now let's just try one more sketch here, and let's use this house This really crude crayon drawing of a house. We'll use the control canny for the sketch again, and we'll say, let's just jump right into Diffusion and take our prompt from there. So let's go projects, types. Let's see what the greenhouses look like. Okay, I really like this. What is this? Countryside school in Belgium. This is really nice. Let's take this image here. I like the burst of color on the stair. I like the greenhouse with the building inside of it. So modern glass house with exposed steel frame, sawtooth roof profile, ceiling glazing panels, colored staircase feature, brick accent base elements, minimalist steel and glass facade, open plan. Okay, this looks pretty good. I'll modify it a little bit to get rid of the sawtooth roof. So industrial sawtooth roof profile. I will change this to a pitched roof profile, like our sketch has here. I will add colorful, vibrant chimney. Get this little chimney here. Staircase. And I will add sitting on a hill. And that looks good. We'll leave the rest the same. The prompt is still more important. And maybe let's run one of these and then we'll try a couple more where the control net is more important, or where we have a balanced control mode. Okay, so we've got some results from that generation, and let's see what these look like. Okay, so I think this one sort of most closely follows our control prompt. They all seem to have the pitched roof in the correct place, but not so much adherence to this less conventional extension down the hill. So let's see if we can make, let's try a balanced generation to see if that will improve the adherence to the control sketch. And I don't really love this style, but we'll continue and we'll just generate some more like this. Okay, so it looks like we got some generations here. These are really bizarre, just uncanny. So you can see what happens when we go from my prompt is more important to the balance control mode. I think ControlNet, if we say ControlNet is more important, it's going to make these results even more bizarre. So let's just try reducing the CFG scale and then saying that we want a balanced control mode and see if that does anything to kind of free up the image generation process from the ControlNet. Okay, so we can see that did not work at all. Lowering the CFG scale simply took us further away from what we wanted in our prompt, and the balanced control mode, it still results in the appearance of our sketch. So clearly, I think for a lot of the generations that you want to do using the ControlNet, I think my prompt is more important as a best control mode, and then we can play with the CFG scale, play with the prompt, to see how that impacts our results. So the next thing I want to do is use an image of a massing, or like an Arctic view of a past project of mine, to show how we can use that in here instead of a sketch. So the previous ones were sketches. Now we're going into like an Arctic mode of an existing model. So I went into this old Rhino model, just kind of spat out this rendering really quick, no materials applied except for the glass, and then we can test this out with the canny, and we can test this out with the depth detection. So if we run that depth map, now we can see it's much more useful when we actually have an input that has depth to it instead of just a simple sketch. So let's try this with the depth. We're going to stick with my prompt is more important for now, and let's modify this prompt. So I'm going to go back into Sare, and I had a project pulled up here that I really liked. So this is, what is this? Chendonghua Architects Non-High Primary School. I hope I'm saying that at least decently. And we're going to find a good image of this. Something that kind of resembles the style or the perspective that I already had set up there. I think let's try this image. And we want to try to leave the people out of the generation. Okay, so it gave me a pretty good language that I can paste in here and modify a little bit to get more what I want. Modern pavilion, public building with dramatic overhanging metal roof, translucent retractable curtain walls, detailed, intricate space frame, roof structure, elevated white platform design, minimalist Japanese inspired architecture, not a residence, steel truss roof structure. Maybe I'll leave that in, but I'll change it to white. Indoor outdoor space, glass and fabric facade system, aerial architectural photography. I'm going to remove the aerial and change that to perspectival. Urban design, I guess. Why not? Contemporary architecture with movable transparent screens, floating roof pavilion, structure white steel frame construction, Zenlight open plan. I'm gonna remove that. It's not really open plan. Industrial elegance tree canopy in foreground. I'm gonna say public plaza in foreground. Retaining wall supporting back of building, city skyline background. Just trying to be as descriptive as possible. And we're gonna say that my prompt is more important. We're using the depth map, and let's see what we get. Okay, so this is an important note. I get the attribute error, ControlNet object has no label. This is because I was using the non-XL depth map, so I need to use the Control-XL depth map because I'm using the ArcViz XL model. So let's try that again. Okay, great. We've got some results here. Let's see what these look like. Interesting. Okay, so it adhered to the ControlNet really well. And it's sort of lifting the thing up above the surrounding context. So in future videos, in the image to image and segment and in paint anything videos that are coming up, we'll go over how to isolate and mask off certain regions of an image to only apply the prompt to those regions. But for this video, we're just focused on first sort of introduction to the ControlNet. So that's super interesting. I want to try to get a little bit less glass. Translucent retractable curtain walls. So let's replace translucent retractable curtain walls with perforated metal mesh walls. Or just perforated metal walls. Intricate space frame, elevated white platform design. Let's go with middle facade system. Public plaza in foreground. Okay. So I removed the references to glass. Let's put it in there. And let's change this to, why don't we try Juggernaut? Let's try that. So I switched to Juggernaut, and I'm gonna keep it at my prompt is more important. And let's try the canny edge detection. So we got canny control XL that matches the Juggernaut XL model. We get a good depth reading there, or edge reading there, and let's generate that. Okay, so here are results from the Juggernaut trial. Less architecture specific models, so we've got a bit weirder results in the facade. I don't love that, but I think this is something I've encountered with Juggernaut before, where I prompt for a metal mesh and the scale and sort of connectedness of it is all off. So let's try the architecture real mix. Just waiting for it to switch over to the new checkpoint model, and we'll generate that. So I'm going to interrupt this generation because I realized that I used the XL canny model, and you can see that the image we were going to get was not going to follow the canny detection because we need to use the we need to use the standard canny edge detection because we have a standard checkpoint model. We're not using an XL model. So here we can already see that it's conforming to the canny edge, to the edges of the input image. Okay, great. Now we've got some results using that canny edge model. I'm sorry, using the architecture real mix model, we got some new results. We've been trying to kind of replicate the style of reference images just using the prompt to control the materiality, context, and things like that. However, the quality of these individual checkpoint models is still really dominant. So in the future LoRa video, I'll show you how to create what's called a LoRa model that we can attach here, and there are a few samples of, so that we can really start to have control over that style based on data sets that we train and generate our own LoRa models. So I'll show you how to use and train your own LoRa models based on images that you would like to kind of reproduce the style of. Hi guys, just wanted to give a quick update to this video. In a previous version, I'd only used one ControlNet tab, but I've actually found a way to use two. It's similar to the image-to-image process that we're going to use with in-painting, but it allows you to do it from the text-to-image tab, and it's a pretty exciting workflow. So first, what we're going to do is select an image where we want to replace a piece of architecture. And so I've selected, for this walkthrough, let's use the vessel here. Let's see what else we can come up with to put into this plaza. First thing, save the image in the correct aspect ratio that you want to use. So this is in 16.9, and I've already got it saved. And then what you'll do is you'll put just a white background over the image. I like to lower the opacity a little bit to make it easier to sketch over. And then just with a black brush, draw in the geometry that you want to try out to replace it. So I've drawn this over the area that I want to replace. And then we're going to turn back up this opacity and then save this as a new image. That we can use as a canny edge. So I'm going to go into my ControlNet here, and in the first tab I'm going to use the original image of the vessel without my sketch. And in the control type here, choose in paint, and you'll see that your cursor comes up as a small brush. So you can hold control and use the scroll wheel to increase the size of that brush, which I'm doing here, and then I'm going to paint over the region that I want to replace, the region that my sketch is going to replace. Okay, and then I've updated the enhanced base folder since the original installation tutorial to include an in-painting ControlNet model. So when you select the in-paint here, your preprocessor will already automatically set to in-paint only, and then you'll just need to refresh this and select your in-paint model. So let's see what that looks like. Okay, and so it just shows a dark cloud around that region. And so in the second ControlNet tab, we're going to put in our canny edge, our sketch that we made for our new geometry. We'll allow preview, low VRAM, pixel perfect, select canny, do that. That looks good. And then it's important here that we say our prompt is more important. If we don't do that, we're going to get an image where we can really clearly see our sketch lines, and they're going to be really dominant in the final rendering. So this all looks good. I will change the resolution to 960 by 540 to match the aspect ratio of the image that I'm providing. I'm going to increase my batch size. Let's do 6 different images. And let's reduce our CFG scale to like 4. I've got a random seed. And in this version, I'm going to switch the schedule type to Keras. Increase the sampling steps. Let's go up to 30. And let's prompt. So I'll go raw photo, exterior, architecture, and let's describe the building that we want. So what do we want to put here in Hudson Yards? Let's just match the style of the shed there. So okay, so I've got my prompt done. The rest of this looks good. I've got balance control mode on the in-painting, and on the ControlNet, on the canny edge, I've got my prompt is more important. Let's try it. Okay, we've got 6 images here. Cool. It's kind of blending into the background a little bit here, blending into this building. And some of these, it's connecting with the existing image. But as you can see, like everything that we didn't in-paint is left the same. Okay, so here are some of the other results that I got using this workflow, doing different sketches over the in-paint region, providing different prompts and seeing what results I get. So with each one of these generations, I'm modifying the prompt. Obviously, I'm modifying the sketch. I'm leaving the in-paint region the same. I'm playing around with different checkpoint models, the original stable diffusion models, not the XL models, and changing the CFG scale and modifying the control mode to see if a balance control mode or a my prompt is more important mode will produce better results. I'm also playing around with LoRa models throughout some of these generations, so if you want to see how to do that, go check out that video. It's in the same playlist as this video. Thanks.